Let's talk inverse functions. Section 6.2 is about inverses, the functions in relations. So let's remember from a few chapters back what a relation and a function is. So a relation is a set of ordered pairs. A function, remember, is a special relation. It's a relation in which every x value from the domain is only paired with one y value from the range. We can look at points to determine if we see y is repeating. The other way is if there's a graph given, we use the vertical line test. Okay, so please remember to make sure you remember everything about a function. All right, so what's an inverse? An inverse is when the set of ordered pairs in the x and the y are exchanged. So we flip-flop the x's and y's. If you have an ordered pair, literally the x's become y's become x's. If it's an equation, we switch the x and y and solve for the new y value. Okay, so domain becomes range, range becomes domain. So let's look at our first example here. Our first example is a set of ordered pairs, and we're asked to first determine, is this just a relation or is it actually a function? So if we look here, we're going to see if each x is only paired with a y. So we have 2 with -1, 5 with 4, but now 2 is being paired with 6, and it had been paired with -1. So therefore, that domain is being paired with multiple range values. So this is not a function. Okay, it's just a relation. Now we're going to be asked to find the inverse. So the inverse, we're literally just going to flip-flop the x and y coordinates. So instead of 2, -1, it'll be -1, 2, and so forth. Instead of 5, 4, 4, 5, then we'll have 6, 2, and -1, 4. So is this new inverse a function? So if we look, -1 is being paired with 2, 4 with 5, 6 with 2, but now -1 is being paired up again with something else. So the inverse is not a function either. Okay, now you can have something be a function, but its inverse is not, or you could have something that's not a function and its inverse is a function. Okay, you try number 2. All right, what if we're given an equation? How do I find the inverse of the equation? Or if I'm given a graph, how do I find the inverse of a graph? Well, the first thing to make sure you know is our notation. So when I see f of x, that means our function. Inverse notation is f to the -1 of x. Okay, and that's because of like our negative exponents. Remember, with the negative exponent means we bring it down, so it's the reciprocal, and reciprocals are inverses of each other. So that's why we use that symbol. So whenever you see f to the -1 of x, it's saying find the inverse. So for these two problems, you're given equations and you're asked to find the inverse. Then you're asked to graph the function and the inverse. So I'm going to do number 4 with you, since that one's a quadratic and a little bit more elaborate. And then I'll ask you to go back to number 3, and that one is a linear function. So let's first find the inverse. So to find the inverse, remember, okay, that when I have f of x, that really just means y equals, right? And so to find an inverse, all we're simply going to do is flip-flop the x and the y. So I flip-flopped where x and y are. However, we're not going to leave it like that. We're now going to solve for y. So I would subtract 1, x minus 1 equals y squared. And now we take the square root. Remember, when you take a square root, that's a plus or minus. So I get y equals plus or minus the square root of x minus 1. Now, because the equation was in terms of f of x, we should go back, and instead of y equals, when I'm finding that inverse, let's use our proper notation. So the inverse, f to the -1 of x, equals plus or minus root x minus 1. So there's my inverse. Okay? Again, I just put a y where I saw f of x, then I flip-flopped x and y, and solved for that y value. Okay. Now we're asked to graph. So I'm going to use two different colors here. Let's use orange to represent the function that was given. So this one, hopefully we can do pretty quickly, right? It's a quadratic, and it is the parent function moved up 1 unit. So we're going to take our vertex from the origin and move it up 1 unit. And then, as we recall, since there's no stretches or reflections, we'll go up 1 over 1. And from my vertex, we'll go up 4 over 2. And then we will connect. So there was the original function. This was function f of x. Now we're going to go graph the inverse. We haven't quite learned how to graph radical functions, right? This is a square root function. So there's two things that you can do. The first one is we can just make a table of values. And then I'll show you another way to do this. So the table of values would simply be to make our table and pick some points. Now, we don't want to pick any negative points because a negative inside would give me an imaginary answer, which we can't plot. So honestly, the first point I would just plot is, check out, is 1. And 1 minus 1 is 0. The square root of 0 is 0. Then I can test 2. 2 minus 1 is 1. The square root of 1, the plus or minus square root of 1, it gives me plus or minus 1. So we really get 2 ordered pairs there. Then I could do 3, but I'm not going to use 3 because 3 minus 1 is 2 and the square root of 2, that's not a pretty number. So I think the next point I would test would be 5, because 5 minus 1 is 4, and the square root of 4 is 2. So I get plus or minus 2 there. So I can plot that. 1, 0 is here. Oops. Apologize. Let's get the eraser. Okay. 1, 0. Then we have 2 at positive 1 and 2 at negative 1. And then 5 at 2 and 5 at negative 2. Okay, so I would connect those curves there, and you can notice I have now this sideways parabola. Here's the other deal that you can do. Instead of having to make a table of values, what did we learn up above? We learned that if something is an inverse, the x and y values flip-flop. So if this ordered pair in orange was 2, 5, that means we should have the ordered pair 5, 2 in my inverse. And let's look. 5, 2, there it is. It's right here. So instead of making a table, I could just take the points I had from my original function, flip-flop them, and plot those. Okay? Now, so there we have our inverse. And I'm just going to write that this is our f of negative 1 of x. Okay? We have our inverse algebraically, and then graphically we have the function and the inverse. Now, one thing to prove whether you know you did your inverse graph correctly is that a function and its inverse will always be symmetric over the line y equals x. So y equals x is where we have a y-intercept of 0 and a slope of 1. So if we look here, that orange, if I reflected it over that green line, I will be on top of that inverse. I'll be the blue one. So you want to always make sure that your two graphs, if they're inverses, would reflect over this green line. Okay, you go try number 3. Find the inverse algebraically by flip-flopping x and y's. Then go ahead and graph the original line, and then graph the new inverse that we get. Again, they should reflect over that line of y equals x. So you can always then check that. Okay, go for it. Next part on page 2 is verifying inverses. So if I asked you, are these two function inverses? We have a couple of ways to do that. You could literally go find the inverse of each to see if you get that same answer, or we can use a composition of functions. So 2 functions, f and g, are inverses if and only if both of their compositions give us x. Okay? So that means f of g of x has to equal x, and g of f of x has to equal x. If that's true, then they're inverses. So let's test out number 5. Let's first find f of g of x. So if you recall from our last section, our composition, we take g in this case, and we're going to plug it in for f. So we'll have 3 times 1/3 x minus 3 plus 9. I'll simplify that. 3 times 1/3 cancels to just be 1x. 3 times -3 is -9. And if I simplify that, we get x. So that is good news. F of g of x equals x. Now what we need to do is we need to do the opposite. We need to now find g of f of x. So I'm going to take f of x and plug that in for g. So that would become 1/3 times 3x plus 9, and then minus 3. If we simplify, 1/3 of 3x is x, 1/3 of 9 is 3, and now we simplify and we get x. So both compositions gave us x. That means these are inverses. Okay? You try number 6. Find the composition. Just always make sure to double check your work, because if you make a little mistake, you may get a false answer. So find the compositions, see if you get x. If you do, they're inverses. If you don't, they are not inverses. Okay, and last but not least, we've talked about the vertical line test. The vertical line test proves something is a function. The horizontal line test is used to prove the inverse is a function. Okay, so if I look at this first example of this graph, this is going to be a cubic graph, right? We're going to determine whether the inverse is a function. So I could determine whether this guy is a function with the vertical line test, right? A vertical line test means if I pass a vertical line through and it only hits once, it's a function. So this is absolutely a function. It passes the vertical line test. But the question is its inverse a function? So we could go ahead and try to graph the inverse and then use the vertical line test through that, or simply we just use the horizontal line test. So the horizontal line test says if I pass a horizontal line through the graph, every point and so forth, does it only hit once each time or does it hit twice? So in this case, again, right here, it's only hitting once. So that's good. And I keep on going all the way down, and I can see it will always, a horizontal line will only hit that blue curve once along every spot. So therefore, this passes the horizontal line test. So its inverse is a function. Okay? So for number 8, you're given an equation. How would I know if its inverse is a function? Well, we could go find the inverse, then go graph it, and then use the vertical line test, or we can just simply graph this guy, which you should all be pros at now, and then use the horizontal line test. If it passes, then its inverse is a function. If it doesn't, its inverse is not a function. All right, so finish up those problems and then submit. Have a great rest of your day.